Level 18. Almost there, y'all. Almost distinguished. Keep it up. Today we're going to deal with situations where there's a positive coefficient on one side of the equation and a negative coefficient on the other side of the equation. So go ahead and make this the title on the next free page in your math notebook. When you have done that, you know the drill. Close it up, concentrate, and listen with me. So in our last and first distinguished level kind of deal here, we had a positive coefficient on both sides of the equation. And today we're going to level that up to what if one of these is positive or negative, but let me remind you how this worked first. If we drew it, we drew both sides without much difficulty. I'm going to make this plus -2. 1, 2, 3, 4, 5, 6, 7, and 28. And what we did is we said, well, if these are the same, I have x's, positive x's on both sides, I could take 4 off both sides without losing any balance. I could just take those off of that side. I could take those off of that side and redo it. And now I have an equation that is fairly typical that I know how to solve. So we added that kind of new thing. It would have been the same. I'm going to go all the way back to the start of this. This would have also worked exactly the same way. I don't think we did any this way if both of those coefficients were negative. If this was a -4 and this was a -7 and they still matched, we still could have done that same technique. I don't think we did. I could have done 4 opposite of x's, -2, 7 opposite of x's, 28. And we still also could have said, oh, look, I can take 4 of those off each side because they match. As long as you're taking the same thing off both sides, it doesn't really matter what it is. It just has to be the same. And then we could have solved this. No problem. We probably would have put -28 on both sides to get rid of this. Those would have made -30. We would have found out that opposite of x is -10, which means x is +10. So we didn't do one like that, but we could have. So today what's going to happen is, what if there's a negative coefficient on one side and a positive coefficient on the other side? That changes the situation quite a bit, and let me show you why. When I go to draw this, this side's going to have 3 opposite of x's and a -2. This side's going to have 7 positive x's and a 28. And what's wrong now is I can't take this off this side because I don't have any of those on the other side. So our strategy from last week doesn't work because, in order to take these off of this side, I have to have them on the other side too. So there are situations where you can't use that strategy, and I'm going to show you a neat tactic to fix that instead. So you remember, when it comes to numbers, let's say I was dealing with this 28, which I'm going to do later in the problem. There was 2 ways to kind of get rid of, so to speak, that 28. One was to take it away, which is to say subtract 28 from both sides. That's one way to do it. But we also had another way to do it, which is to put its opposite thing on that side. So another way I can get rid of that +28 is to put a -28 on each side. And that will also do that. So there's 2 ways to do that. Same thing goes with the variables. If I don't have a way to take these off this side, and I don't because there's nothing on the right, the other thing I can do is put its opposite on this side. I can add 3 positive x's on that side. And when I do, and you combine all those like terms, those will be gone. So that's what I'm going to do. If I can't take them off, but I'd like to get rid of them, I'm going to add +3x to each side. And that's my other path to getting rid of all those and now having an equation I think I can solve. There's going to be, 10 total of these? now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a 28. And now I'm back in familiar territory where I know how to solve this. I can, same thing, now I've got to deal with the 28. I'll put negative 28 on that side, put negative 28 on that side, and now I've got negative 30 here, 10x's here, and I can figure that out. Each x would have to be negative 3. So that's what I do. If I need to get rid of something and I can't take it away, I instead put the opposite on there. Just like last time too, where I said it kind of doesn't matter which, I also could have done this. I could have, well, let me not say that. Let's just leave it there. I think that's clear enough. Let's go to inverse operation. Plus negative 2 equals 7x plus 28. Inverse operation, I'm going to do a similar thing. So I'm either going to decide to get the x's off of that side, or I'm going to decide to get the x's off of this side. It doesn't matter which. Either way, you're going to come out with the same answer. I think I told you last time I tend to deal with the smaller number. I'm not sure why. So if I didn't want 3x on this side, I would add 3x to that side to get rid of them, and I would do that here too. So that's going to leave negative 2 equals 10x plus 28. Now, normal finishing stuff, subtract 28, and you'll get negative 30 is 10x, divide by 10, divide by 10. X equals negative 3, just like we got there. If I rewind a tad, go back to the beginning, I said it doesn't matter which one you deal with, and let me show you that. If instead of taking the 3x off the left, I wanted to get rid of the 7x on the right, I could do that as well. I could subtract 7x or add negative 7x, either way. That would get rid of that. So put a negative 7x here too. I'm just going to have negative 10x on this side, plus negative 2 equals 28. You'll notice that the first time I went through, I kind of got rid of this. Instead, this time I'm just showing you that I'll get the same thing if I get rid of that. It doesn't matter which side you deal with your x's on. Now from here, I would add 2 and get negative 10x equals 30. I would divide by negative 10, and I would get the same thing. I would still get x equals negative 3. So it doesn't matter which of these you choose to deal with. That's what I was about to say over here. If instead of adding 3 x's on both sides, I'd added 7 opposite x's like I did this, I still would have gotten the same thing. So it doesn't matter if you choose to get rid of those or you choose to get rid of those. As long as you get all your x's to one side, you'll be okay. All right, let's do this one together. If you want to pause and add this one to your math notebook, and unpause when you're ready to go. Love the visual strategy when there's variables on both sides. Love it, love it, love it, love it. This is what's new if you want to make a note of it. It's for when you look back your notes. Negative coefficient on this side, positive coefficient on this side. That's what's new today. Just like you to keep track of what's up. That's a new thing. And what's new about it is if we try to apply yesterday or the last lesson's tactic, it doesn't work. So I would have negative 6x on this side, or 6 opposite x on this side, and a 9. And I would have 4 positive x on this side, and 14. And you'll notice I can't group the x's with yesterday's strategy. I can't just take this away because they're not over there. There's no x's over there to take away. And I can't take the negative x's away because there's no negative x's on the other side. You can only take things away from both sides if they match. So I've got to figure out a way to deal with this otherwise. So what I'm going to do is I'm either going to add the opposite of these on this side, or I'm going to add the opposite of these on this side. It makes no difference which way you decide to do it. You'll get the same answer either way. So some people choose to try to eliminate the smaller number. There's 4 here, there's 6 here, so let me deal with that. Or some people also prefer to always keep as much positive as they can so they don't make mistakes. So in that case, you might want to add positive x's here and here so that you are dealing with positive x's and not negative. Doesn't matter. Either way you decide to handle this, you'll be right. So I think I'll add 4 opposite of x's over here. Again, you can do it the other way, and if you want to do it the other way, go ahead. So if I add 4 opposite x's over there, I've got to do the same here. Now when I redraw, those are going to eliminate. So I've got 10 negative x's here. Nine and 14. And now I'm ready to go. There's nothing new anymore. That was my tactic, was get all my variables on one side. Take away 9, take away 9. I'm going to be left with 10 of these. And 5 over here. So there's 10 of those, they make 5. Each of those, remember how to deal with this opposite x. I deal with them like they're a variable all together. So in this case, each of those would have to be positive for them to add up to 5. So opposite of x would have to be positive a half, which means x would have to be negative a half. And that's how you do it. I think the visual strategy is by far my preferred strategy when I run into this situation where there are variables on both sides. I think it's just much clearer. I'm going to do the inverse operation strategy for you too. I just probably prefer the drawing strategy on this one myself. So here we go. All right. So my choices are to eliminate this or to eliminate this. It does not matter at all which one you choose to do. Whatever you prefer. This side we got rid of the 4, so maybe I'll do the opposite here. I'll say let's add 6x to both sides. The benefit to that is you'll notice now we're going to be dealing with positive x's or positive coefficient, which sometimes people find better than dealing with negative like we did over here. But again, it doesn't matter as long as you do everything right. So now everything's positive here. I did that to get the variables all to one side. And now not much to it. Subtract your 14. Divide by 10. And we get x equals negative 5 divided by 10, which is negative 1/2. Just like we found there. So that is what you do, guys, to get very distinguished. If you have positive coefficient, a positive x's on one side, and negative coefficient, negative x's on the other, is instead of taking something off both sides, you put some variables on both sides, and it all still works out. Hope this made tons of sense to you. If you need to give this another watch to make more sense of it, please do. I want you to feel confident that you really understand this new distinguished skill. When you do, I will see you on the next one.